So the next section we're going to talk about here, Daniel Valdivia and AB are going to primarily drive this, but it's about critical capabilities in the multi-cloud. And so we've talked about performance a lot. We're going to show you some of the ways that we actually demonstrate that within the product and show you kind of what kind of speeds we're seeing today. We're also going to talk about that from both the large object and a small object perspective. One of the reasons that we're intensely focused on small objects is that you find them across all of these workloads. So AB talked about it from a database perspective, but you also find it even in archival workloads in terms of the size of the objects, and being able to deal with small objects is a critically important part of it. And then we're going to talk about data protection, so continuous data protection. And then multi-site active replication. So those are the three things that we're going to talk about: speed test, continuous data protection, active multi-site replication. And I'm going to turn it right back over to Daniel.
All right. So I also set up an instance here on the cloud. And this is very important because the fact that you're in complete control of the infrastructure, you can size your tenants to your needs and to your performance characteristics, right? So I built a small, AB was also mentioning about the capability of being able to ask MinIO, okay, benchmark yourself and tell me how fast can you go with the infrastructure that I'm giving you. Right now, what I'm going to do is pretty much do that. I'm going to ask MinIO, okay, can you do a performance test on your own infrastructure and tell me how fast can you push? So this is great when you're provisioning different tenants with different capabilities, right? So if you're doing some archival, perhaps you want to use the lower tier persistent volumes that the cloud provides, right? Hard disk drives, they're slower, but they are cheaper and deeper, right? So for machine learning, let's say I want to have some very fast training, right? This setup, for example, I can actually read up to 148 gigabytes. Again, these are gigabytes, not gigabits. If these were gigabits, I guess we will have been past the 1,000 gigabits of throughput, right? And here I get a breakdown of individual server capabilities, right? I have 32 servers. And you can see, for example, this fun fact, I'm actually running this tenant on a Graviton set of instances, right? That's kind of like the plot twist, right? I'm not even bounded by the architecture of running everything on x86. So if for certain use cases, I see that the Graviton instances have like a great bandwidth and EVS optimized bandwidth, right? I can actually leverage them, and I'm rated to get 4.75 gigabytes maximum per VM, and that's exactly what MinIO is extracting out of each of these ones. And just to do this one more time, like right now, I show you doing this sort of like supportability debugging using CLI, but that's also something that you can also do easily with MinIO, the console user interface. I can always come here and say, well, let's do a benchmark here and get the same kind of experience, right? I don't need to even memorize that command that I was showing you if I can also do it in a visual manner. So yeah, I mean, this is probably the whole part about speed test, right? So let's see. Let's get some numbers and move on to the next part. You see the same numbers, right? 149 gigabytes a second and a breakdown of the 32 servers that this instance has. So you can see I'm pretty much putting all the capacity that the infrastructure that I'm actually provisioning can get me. I'm extracting it with MinIO. So then another part that we were talking about was the need for continuous redundancy of the data, the no need for snapshotting data, right? So that's the next part of my demo. I'm going to log in here into a tenant where I have a variety of buckets, and I have a bucket here, right? So let's say I had some very important data, and some people have said now it's lost. You should have been snapshot, but in object storage that's not the case. Object storage has the capability to actually do versioning. So I can, instead of being snapshotting my instance to be able to retrieve files that are lost, I can simply just go back in time. Let's say I want to go back to how this bucket was today, 12/15, right? And get that data. And I see that my files were actually back then, right? So someone deleted them now, but I can still retrieve those files, right? So there's no need for me to even be backing these things. I can endlessly have unlimited number of versions and go back an insane amount of back in time. And then even if this becomes a problem with lifecycle management on MinIO, I can even have these older versions be set to expire and remove automatically. So I don't even need to be doing any management of the data that's actually aging on top of my infrastructure, right? And the last part that Eric was interested also in knowing about was, okay, how, if I'm getting all of these consistent applications across the cloud, how do I go about dealing with replication, right? So in this case, the demo that I prepared for you guys is, you saw me, I had this Google bucket, right? So which I'm going to actually place on my left side. And I have these other buckets that I have on Amazon and Azure, right? So right now they happen to have the same amount of data. I'm just going to quickly hit refresh and make them fit on the screen. But I can actually come to this bucket, and I actually set up ahead of time some replication, right? I made it so I set synchronous replication between both clouds, Google and Azure and Google and Amazon. So I can pretty much just go to this bucket and drop any file. Let's say here I'm going to upload another file. Let's see, I'm going to upload this GIF, right? So, and I can immediately go to my Amazon bucket, and I see already the file here, right? It got copied right away, right? And this is because I set up synchronous replication, even though these clouds are apart, and the latency between them, you know, sometimes it's small, sometimes it's large. And it's hard to tell, right? So now my Google Cloud could go down, and the data is already replicated both to Amazon and to Azure, and I don't have to do anything, right? So that's the part where we were talking about replication.
Exactly. And can that be done bidirectionally?
Yes, it can be done. I didn't set up the demo that way, but it can be done bidirectionally. I'm going to put a bunch of GIFs on my Google bucket and just keep refreshing my Azure. You see, as the files keep getting uploaded, I'm getting them right away on these other clouds, right? So this is Azure. I'm going to go back to Amazon. The data is there, right? So again, I simplify the operations of my object storage. Applications will be able to keep working as regular, even if there's a failover situation where I need to go from one to another.
Yeah, just to one point to add there is it's not only bidirectional, it is also, you can configure it at a site level. So you don't want to be like setting every bucket you create, you forgot to set the replication policy. I just want every bucket created to automatically inherit this policy. You can set it at a site level. You can also do multi-site active-active, and it is all bidirectional. And when the demo you're seeing here is a synchronous replication across the cloud. And that means it is also strictly consistent even across the cloud. Applications will, if once you get 200 OK after the commit, you are guaranteed that if you go and do a list or any operation you perform across the site, they are strictly consistent.
Okay, and that's obviously parameterable. So I can say this is synchronous, this can be asynchronous, or so we have those options. Okay, great.
Yeah, there is in fact like the asynchronous operation. You will not notice that it looks like it will look like synchronous because it triggers a replication right after the commit happens. And if it's in this case it's a 32 node cluster, every node equally participates in distribution. So as long as your internet bandwidth is there are actually several production deployments with like 130, 150 millisecond latency. This is cross geography and cross cloud, and we can still handle synchronous replication or asynchronous replication across the cloud at that distance.
So as we go back and we talk a little bit about the speed portion of this, we just published a new benchmark back in January. We pushed 345 gigs a second on read, 148 on write on that 32 node AWS instance untuned, right? We have some upcoming data from one of our hardware partners where I think we're going to be able to show numbers for similar size in the 500 gigs per second range. So we're continuing to see growth in that aspect of it. And again, performance is not really a vanity number for us. It means we can run more workloads. And so why are we so fast? Well, first of all, we're a single layer. I think we said at this beginning, but we only do object storage. All our eggs in that are in that basket. It's the only thing that we think about. We're not making compromises that you have to inherently do for an integrated file block object platform. We just do object storage, and we're only focused on optimizing for that. The second part is that we don't have a metadata database, right? This is an architectural decision that we made very early on that allowed us to basically choose to write the metadata atomically with the object. So we don't use a third-party database like a Cassandra for the metadata. Those things do struggle at scale. They struggle with small objects, and these are well-known problems in that area. That allows us to be hyper fast, even at scale. We also did all of the grunt work associated with SIMD acceleration. So we got down and we wrote at the lowest possible level, whether it's AVX512 or Neon optimizations, to make sure that we could run on commodity hardware and run fast. And then we also wrote in Go and Go assembly language, so we could target the performance to run very, very quickly against certain tasks. And that AB talked a little bit about that earlier. And so that's the reason that MinIO is able to be fast. And that architecture, I think, will keep us ahead of a lot of other folks in this industry on a go-forward basis. So let's conclude. What does the future look like from a cloud storage perspective, right? So one, we think it's software defined. It's characterized by YAML, not proprietary hardware. You can't containerize an appliance. We say that time and time again. We feel very comfortable that world is software defined. We also believe in the overall theme that we're seeing time and time again around disaggregation, whether it's high-speed query processing and storage, whether it's a separation of compute and storage that we're seeing on the HDFS side, which is driving a huge portion of our business as companies migrate and modernize their workloads from that perspective. Kubernetes is the compute, object storage is the storage. We're seeing that model everywhere that we go. And then finally, this concept of multi-cloud, right? So we think this is a business imperative. We think it's a business imperative from a cost perspective, from an application portability perspective, from a lock-in perspective, from a business continuity perspective, from a regulatory perspective. You're going to see more and more multi-cloud. And you're not just going to see more and more multi-cloud, because I think according to the data that came out again today from Flexera, the number's 90-something% from enterprises saying they run multi-cloud. But what we mean by that is that you're going to see more and more clouds in that multi-cloud architecture. So it's not going to be, one private, two publics, or two privates and one public. It's going to be 3, 4, 5 of each. And that's going to become more commonplace as you can start to abstract the differences that exist across those clouds, again, using a consistent data storage infrastructure coupled with Kubernetes to abstract what it is on the hardware side.
Do you have an updated customer count?
Yeah. So we are just over, I think, 200 at this point.
One change we also made as a business, as the number of customer counts started growing faster, we started focusing on mid to large, more so large, because if you see this really small ones, product is so simple, but they're also quite chatty, right? We are more focused on ARR growth, and as a business, we got the community industry adoption, and the small customers, they're not going to go anywhere. Our goal is to keep it so easy that they can take care of themselves. As a business, we are more focused on mid to large customers, typically in petabytes range as a starting point, and 10 petabyte and above as basically our sweet spot.
So when you say customers, does that mean like other vendors like Veeam and Portworx that are using your solution?
Yeah. So they're Veeam customers, for example, like Portworx actually would recommend MinIO all the time if you're looking for object store. Veeam itself, for their backend, actually there is a lot of users using it. In fact, we find Rubrik, Actifio, Rubrik itself is a customer, and they are more of a co-sell type relationship. And then there are some OEM partners too, all the way to Seagate Live Cloud itself is MinIO, right? But the primary ones, what we like is the mid to large enterprises, all the way to the enterprises who think of themselves as hyperscalers.
Yeah, that's the PayPals, the PRGXs, the Boxes.
Yeah, and some companies we can name, but you recognize as the most prominent brand today.
Yeah, but Becky's point is actually a really interesting one, though, because you guys have at least 3 different customer sets that I can think of, and it must be challenging to run a company that way, because on the one hand, you have the developer open source customers. On the other hand, you have the enterprise customers who are basically buying and paying and using. And then on the other hand, you have these OEMs who are using you as well.
Yeah.
Do you consider all three of those to be customers, or is it only the middle category that's a customer?
Yes, actually, that points back to, like, when we say developers, like, what does it mean, right? These are not developers of object store. If you are talking to a database company, right, who are your customers? Who are your users? Developers. Who are users of object store? Developers. When we say developers pounding on MinIO, these are actually users pounding on MinIO. More users pounding on MinIO means more bugs.
I don't want to go down this rat hole.
Yeah.
But it's, as a developer, if for some reason I was using MinIO to test the stuff and I determined that MinIO wasn't working, I might say something to you about it, and I would immediately go find another tool to do what I needed to do.
Yeah, if that was true, right? Like, MinIO's community will be very small, right? That is where that having a huge user base, it gets us to test. In fact, we make new releases every week, right? So it gets us to test rapidly on a large install base using your users to do QA. The more users, the more proven you are, the more testing happens. But then it sounds scary, right? But that's actually how cloud world works. There is only one stable version of S3. That's the one that's running in the production. And every commit they make, it actually pushes to production. And then the users of the S3 report bugs. There are always failures happening in the cloud, but then they get caught. They're isolated. No failure takes down everything. MinIO's case, that, like, the speed at which we are moving, every week, if you see, right, like the number of commits that's happening, we should be causing data loss and all kinds of outage left and right. It doesn't happen. It's because of the cloud way of doing things. Now, back to our customers, right? Like we actually don't see three class of customers. Our customers, if you see within the organization, IT has no use for MinIO if there is no application for MinIO inside the organization. By the time IT discovers, it's basically developers who built an application on MinIO and then took it to production, and then they go and ask IT at some point, I want 5 petabytes of drive space. That's when IT recognizes that there is MinIO, and there are many MinIO deployments inside the organization. Without we targeting developers, we are not a developer tool. Developers are the users building applications. And today's time, if you see, the journey to the cloud starts with app modernization. If the apps are getting rebuilt from scratch to be cloud native, if I talk to IT will find no use for MinIO. I have to get the applications going into production along with MinIO, and then IT comes in to standardize on MinIO. The journey looks very close to a database business model.